Okay, so now for some reason we've done galvanic as a graph question, and this graph is EMF versus the concentration of M+. And if we just look at this quickly, it's always alphabetical, it's always cathode on the right-hand side and anode on this side. This is called cell notation, and it is telling you that the aluminium forms Al3+ and is oxidized, and the M2+ forms M and is reduced. The cathode is always reduced, it's red cat, and the anode is always oxidized, it's anox, or I don't know, anox. Or you can do oil rig. Well, oil rig is oxidation is loss of electrons, reduction is gain, and it's also fat cat. So the cathode always gets thicker and the anode gets thinner. So now the question is, what is the reducing agent? So this is a bit of unfortunate wording, but the reducing agent gets oxidized. So aluminium is the reducing agent. The reducing agent makes the other reactant get reduced. The reducing agent causes reduction. So the aluminium will be the reducing agent, and it will cause the other thing to get reduced. The reducing agent gets oxidized. Then for 8.2, that's quite a nice question. They're just asking me to read off the graph. I'm not sure I'm going to be able to, but 1.87. So 1.87, this is 81, 82, 83, 84, 85, 86, 87. It's this one here. And then if we go down from that one there, so that's 25, 26, 27, 28, 29, 30. No, this is halfway between these two. And that is a 25, so halfway between will be 12.5, so that'll be 37.5. So halfway between will be 37.5, because from 0.25 to 0.50, it's 0.25 in total, and half of that will be 0.125. Sorry, so this would be 0.375. So we need to figure out, this line here is just over halfway, so if it's 2.5 blocks makes 0.125. Anyway, so you can do it on your calculator, and you should get between 0.32 and 0.33. So that's their answer, 0.325. What you can literally do is, this here is 1, 2, 3, 4, 5 blocks. And 3 of the 5 blocks. So 3 over 5 out of all 5 blocks is 0.125. So then you can actually calculate it. And you can do 3/5 of 0.125. And that is equal to 0.075, so that's 0.075. So then you get 0.25 plus 0.075, which gives you 0.325, which is exactly what they said. But they'll accept anything between 0.32 and 0.33. So reading a graph is supposed to be a skill that you learn by taking this subject, or maybe even life sciences or maths. So what we did there, I don't know whether you just want me to run through it again quickly, is they asked for an EMF of 1.87. So this is 1.85, 1.86, 1.87. So it's that one over there, so it's here. So this one over here. And this entire distance here is 0.25, which means that this half is 0.125. And it's 1, 2, 3, 4, 5 blocks make that. And 1, 2, 3 of the blocks is what I've gone through. So I'm just going to do that again quickly. And then the 0.25 plus that gives you the 0.325. So that's just reading a graph. I'm sorry if it was too fast, but I mean, you can rewatch it 8 times if you need to. Then for the next one, they say, how will the concentration of M2+ be affected as the cell operates? So you choose increases, decreases, or remains the same. M2+ forms part of the cathode, and the cathode, according to red cat, gets reduced. So the cathode gets reduced, and reduction is gain of electrons. So that means that M2 plus is getting reduced to form M, which means that the concentration of M2 plus is decreasing. So there we go. M2 plus is reduced, M2 plus is used up, M2 plus is the oxidizing agent. Oxidizing agent means that it gets reduced. The oxidizing agent gets reduced, the oxidizing agent makes the other thing get oxidized. Then they're now asking about potassium nitrate. They're saying it's used in the salt bridge. So potassium nitrate is K plus and NO3 minus. We must remember, if we're asked about a salt bridge, we must always put a nitrate salt in it. A nitrate salt is always soluble, and we must choose a salt that doesn't have M in it and doesn't have aluminium in it. So the salt bridge mustn't have either of the metals that is in the actual galvanic cell, and you can always choose a nitrate. A nitrate will always be correct. So they're saying that they use potassium nitrate, and they're asking, does the K plus go to the Al or to the M? Does it go to the anode or the cathode? So on the aluminium side is making Al3 plus. The aluminium side is making Al3 plus, and so the positive charge is increasing on the anode side, which means the nitrate would go there. On the right-hand side, the M2 plus is forming M. The positive charge is leaving, and so this positive charge will go and replace the positive charge. So at the anode, the negative half of the salt bridge cancels out the increasing positive charge, and on the cathode side of the salt bridge, the positive charge goes in to replace the positive charge that's leaving. Which electrode will the K plus move to? It'll move to M. So let's just see that on the memo quickly. It'll move to M. See there? And now, I think we're on the last two questions, perhaps. So now, let's just see what it says here. 8.6, where's 8.5? There's 8.5. So it says identify metal M with the aid of a calculation. So metal M, we're going to want to use this table, and the concentrations on this table are all 1 mole per decimeter cubed. So we need to use this EMF. We need to use this EMF, which is 2 volts. And then we can use this table, which is based on everything having a concentration of 1 mole per decimeter cubed. So we use the only formula that applies in this section. And please just always write it from your formula sheet. So it's E cell is equal to E of the cathode minus E of the anode. Please don't write it like I wrote it, but write it, please, from your formula sheet. You don't want to lose a mark because you left this off for something silly. And if you write the wrong formula, you can actually lose all the marks. So this is quite an easy 3 or 4 mark question. I'm not sure how many marks they want for it here. 6 marks. Jeepers. Okay, well, 6 marks is even better. Wow. Okay, so anyway, we got the 2 volts off of the graph. Because we know that the standard concentration for these things is 1 mole per decimeter cubed. If we didn't know that, we just guessed that, because 1 is a nice number. I don't know. So the EMF for this cell is 2. The E of the cathode is what I'd like to work out. And the E of the anode is minus 1,66, because that is aluminium. Always be careful that you're using the correct one. Aluminium only has one version, but always just be careful. How do I know I'm using the correct version? This thing in the beginning told me there was Al and Al3 plus. This is Al3 plus, this is Al. So this is the one I want to use. And then we do a little bit of maths, and we get that the M's reading is 0.34. And 0.34, if we look on this bad boy, 0.34 is copper. So stupid bloody thing, 0.34, see here, 0.34 is copper. So M is copper. I think I'm going to try and stop moving this around because it doesn't seem to be working. But anyway, M is copper. And so we can see here, if I just uncover this part, there we go. So there's the calculation that we did, and you get 6 marks for that. You get 2 marks for calculating that it's 2 by just reading it off the table, off the graph, and you get that M is copper. 6 marks, very nice. Now they are saying that M is replaced with magnesium. M is replaced with magnesium. So let me just highlight it quickly if I can. The aluminium is still being used, but instead of the copper, which I'm going to do in black, so we were using copper at the zero, we were using this one, but now we've changed it to magnesium, which is this one. And that means top right, bottom left. Now everything has changed. Top right, bottom left. Aluminium is now the cathode, and magnesium is the anode. If you are using table 4b, the anode is always on top. So if you replace it with magnesium, Mg will now be the anode, and they want you to refer to the relative strengths of oxidizing agents. So if we can look on this table quickly, which I probably can't do without every bloody thing shifting around. I'm just going to shift this up quickly. See here, so I can move these up as well. So the aluminium and the magnesium, and then I can move that up, aluminium and the magnesium, and then I can put my copper back. And the question is asking about magnesium or aluminium being the anode, and they are asking you refer to relative strengths of oxidizing agents. So the one at the bottom is stronger than the one at the top. So now you need to compare magnesium and aluminium, and you need to say that Al3 plus is a stronger oxidizing agent. Al3 plus is a stronger oxidizing agent. It tells you that with the arrow. It is a stronger oxidizing agent, and the question asked you to talk about oxidizing agents, so we're arguing with the left-hand side, with the things that are on the left-hand side. Al3 plus is a stronger oxidizing agent than Mg2 plus. So that's what you have to write. Al3 plus is a stronger oxidizing agent. They say relative strengths, so the ER is actually quite important. So Al3 plus is a stronger oxidizing agent than Mg2 plus, and will oxidize Mg to Mg2 plus. So that's why magnesium is now the anode. It's getting oxidized by the stronger oxidizing agent, which is Al3 plus. And then just look at it in the memo. What do they say there? Oh, come on, man. I don't want to do multiple objects. I just want to do one object. See there, Al3 plus is a stronger oxidizing agent than Mg2 plus, and therefore Mg will be oxidized to Mg2 plus. So that's what you have to write. And how you know what to write, if you can just remember things, if you're studying things, you use whatever they tell you on the table, and you say, well, the one is a stronger oxidizing agent than the other, and therefore will oxidize the opposite side, which is Mg. So Mg is on the opposite side to Mg2 plus. And so all you need to say is the stronger one, the stronger oxidizing agent will oxidize the opposite side. So Al3 plus is stronger oxidizing agent than Mg2 plus, and it will oxidize Mg, which is on the opposite side. So you see here, Al3 plus is stronger than Mg2 plus, and it will oxidize Mg, because an oxidizing agent makes the other thing get oxidized.